What is an algorithm? How algorithms work. Full breakdown. Intro 45 hook plus promise plus SEO boost. Background music fades in modern, upbeat, touchy vibe. On camera, host with energy, looking straight into the camera. Host. What if I told you there's a hidden system quietly running your digital life, deciding what you see, where you go, what you listen to, even what you buy? It's not magic. It's not mind reading. It's something called an algorithm. Quick cut visuals, YouTube homepage suggestions, Google Maps loading routes, TikTok scrolls, Spotify recommendations. In this video, we're breaking down exactly what an algorithm is, how it works, where you use them every day, and why learning algorithms might just be the most powerful skill of the 21st century. Overlay text. What is an algorithm? Explained simply. Section 10.45.2. What is an algorithm? Cut to host or animation. Clean visuals of flowcharts, step-by-step diagrams. Host. Let's get the definition out of the way. An algorithm is just a set of instructions. It's a step-by-step method for solving a problem or completing a task. Visual. Recipe card appears on screen. Ingredients: mix, bake, done. Think of a recipe. You follow steps to get a result, in this case, a cake. That's an algorithm. It's simple, logical, and follows a clear process. Now imagine a computer doing the same thing, but with numbers, data, or digital tasks. That's where things get interesting. Section 2.003.30. How algorithms actually work. Visual. Animation of a flowchart with boxes for input, process, output. Host. Every algorithm needs three things. 1. Input the data it receives. 2. Process the steps it performs. 3. Output the result it gives you. Example animation. A list of numbers goes in, algorithm sorts them, sorted list comes out. For example, say you have this list of numbers: 23, 5, 8, 1, 99, 14. You want to sort them from smallest to largest. That sorting method, that's your algorithm. There are many different ways to sort. Some are fast, some are slow, and some are smart in very specific ways. Section 3.3.35. Types of algorithms. Cut to visuals of each algorithm type being demonstrated. Host. Let's break down a few common types of algorithms you'll hear about, especially in computer science. 1. Sorting algorithms. Sort a list of things in order. Examples: bubble sort, merge sort, quick sort, used in spreadsheets, databases, search engines. 2. Search algorithms. Greater than. Find an item in a list. Example: binary search cuts the list in half each time used in false search websites. Autocomplete. 3. Pathfinding algorithms. Greater than. Find the best or fastest route. Examples: Dijkstra's algorithm, a star asterisk used in Google Maps, GPS, Game AI. 4. Machine learning algorithms. Greater than. Learn from data to make predictions. Examples: decision trees, neural networks used in YouTube, TikTok, facial recognition, spam filters. 5. Scheduling algorithms. Greater than. Decide the best order to do tasks used by operating systems, factories, airlines. Section 4.2.5 o'clock to 6 o'clock. Why efficiency matters. Visual. Graphs comparing ON, login, ON performance. Host. Not all algorithms are created equal. Some take longer, some use more memory. That's why efficiency matters, especially as data grows. Greater than. In computer science, we measure this using something called big O notation. It helps us understand how performance scales. For example, ON grows linearly with input O login. Much more efficient ON gets slow really fast. Greater than. If you're coding a mobile app or building a website, a bad algorithm can literally crash your system when your user base grows. Section 5 to 6 o'clock to 7:30. Algorithms in real life. Montage of people using different apps: Google, Amazon, Spotify, YouTube, Uber. Host. Here's where it gets fun. You're using algorithms every day. Google Maps. Greater than. Finds the fastest route with real-time traffic data. Spotify. Greater than. Suggests songs based on your listening behavior. Amazon. Greater than. Recommends products by analyzing what you click, browse, and buy. Netflix, YouTube. Greater than. Algorithms suggest content based on your watch history and what others like you are watching. Greater than. It's not just about code, it's about behavior, data, prediction, and personalization. Section 6 to 730 to 815 Ethics of Algorithms. Visual. Faces, data charts, warning signs of bias or surveillance host greater than. But the algorithms can go wrong. If the data is biased, the results are biased. That's why algorithm transparency, accountability, and ethics are becoming critical conversations, especially in fields like hiring, policing, and credit scoring. It's not just about how smart the algorithm is, it's about how fair it is. Section 7 to 815 to 9 o'clock final thoughts plus CTA host greater than. So, to recap, an algorithm is a step-by-step method to solve a problem. They're used everywhere, from sorting numbers to driving cars. Different algorithms solve different problems. With different efficiencies, understanding them helps you build smarter, faster, fairer systems. Whether you're a beginner learning to code, a business owner using tech, or just someone curious about how your digital world works, understanding algorithms gives you power. Call to action, host, greater than. So what's an algorithm you use every day without even thinking about it? Drop your answer in the comments. I'd love to hear from you. Like if this video helped break it down, subscribe for more deep dives into tech, code, and the invisible systems running our world.